Hey again. All right. This is question 4, not question 3, um, where we are trying to repeat the steps from question 3, but instead with a new setup with a woman. Again, we're looking from above, so the woman is getting pulled forward, tension force of 100 newtons. She's getting pulled up and to the right with another tension force of 100 newtons, but at an angle of 20 degrees. And she's getting pulled down and to the left, 110 newtons. But this angle is 28 degrees. For similar reasoning as last time, we could and probably should use this angle because we need it to be with respect to the horizontal. So, excuse me. To determine that, you just do 90 minus 28, 62 degrees. Again, I will always, from now on, give you the correct angle measure to figure out what it should be. I apologize for that. So we have actually not one, but two different angles to deal with, but it works the same process. We got to break them apart into an FTX and an FTY for that one, and an FTX and an FTY for that one. Same idea. You could do it with the 28, just be a little backwards on the sine and cosine. So let's do the 62 degree one first. Doesn't matter which one you choose first, but I just want to show the 62 degree part first. So 62 degrees is here. Our FTY is going to be our hypotenuse, 110, times sine of 62. Our horizontal, our FTX, is going to be 110 cosine 62. 110 sine 62 is 97.12. 97.12 newtons. And our FTX is 110 cosine 62, which is 51.64 newtons. All right, for the 20 degree, again, we use the 62 degree because we flipped it. We want it with respect to the horizontal. So instead of using the 28, we had to use the 62. In this one, it is already with respect to the horizontal. So our FTY and FTX, we don't have to change anything for. I'm going to get my X's better. Is going to be the new tension force up here. So that's 100 newtons, not 110, times the sine of 20. And this one's going to be 100 cosine of 20. 100 sine 20, 34.2. And 100 cosine 20, 93.97. Alright, so we broke those apart. We don't need them anymore. We can get rid of that one, and we can get rid of that one. And we replace it with two forces each. So we're going to have a total of 5 forces on our free body diagram. The first one, Ft, just that's the true full one that's pulling the woman forward, 100 newtons. Our 62 degree, our FTY, well, that's this one. So it's going downward, so it's a downward force. FTY, 97.12 newtons. Our FTX for that one is going over to the left. And that equals 51.64. For the 20 degrees, we have an FTX for this one going to the right of 93.97. And an FTY also going up of an additional 34.2. 2 newtons. All right, so that's our free body diagram. For part B and C, we have to find the vertical net force and the horizontal overall net forces. So for vertical net force, that's the total up minus the total down. The total up, 100 plus the 34.2, so that's 134.2 minus 97.12. Total up minus total down, 134.2 minus 97.12, 37.08 newtons. Perfect. Okay. The net horizontal force is total right, which is 93.97, minus the total left, 51.64. 93.97 minus 51.64. Calculator mistake. 64. 42.33 newtons. Next thing, combine them. So this one is to the right. This one is up. It's a nice triangle. So to combine them to find the net force, the hypotenuse, you go over first. Then you go up. 42.33. And 37.08 our net force, Pythagorean theorem. $56.27. So our F net is 56.27 newtons. And we have to find the angle. The angle is the inverse tangent of 37.08 over 42.33, opposite over adjacent. 42.33, because this is our angle. And the inverse tangent of 37.08 over 42.33, 41.21 degrees. 41.21 degrees, and again, for ease, you can just say AH. So that's part E. And now we just have to find F, which is we got to find the total acceleration. Total acceleration is just net force over mass, so it's going to be our net force divided by 73 kilograms, 56.27 over 73. 0.77 meters per second squared. The angle of the net force is the same as the angle of the acceleration, so 41.21 degrees AH. There you go. You solved question 4. It's 2 forces. You break both of them apart, figure out their their component forces vertically and horizontally, put them all together in whatever direction they should be. This is where it gets you have to be very careful with your tip to tail and how you draw them to make sure that you don't go up and then down. You have to go over, up to get to the end. And we're good. So hopefully you can follow along, and hopefully you got this answer. All right. Good job.